Welcome everyone. Math 103, we're working on section 4.2 today on multiplying monomials. Got a warm up? Please start with that. Just a reminder to pause the video, work on things, and because I'm not stopping. All right, x squared times x to the fifth. When we're multiplying, we're going to add the exponents. So that's x to the 2 plus 5, which is x to the 7th power. Now I've got power to a power. And with the properties of exponents that we learned before, power to a power, we multiply the exponents, we get x to the 12th power. Now we're dividing, so we're going to subtract the exponents. It'll be x to the 8 minus 3 power, which is x to the 5th. And another division problem, this one, we've got a higher power in the denominator, so when we subtract, we get a negative value, x to the negative 2 power. So to simplify, we need to remove any negative exponents. We're going to use the definition of negative exponent. Move that x to the denominator and change the exponent to positive. All right, so when you cross the line from numerator to denominator, change the sign on the exponent. So one of the most important applications of multiplying monomials is if we represent real-world objects as monomials and then we want to learn more about them. So for example, if we have a city park whose length and width are represented by a couple of monomial expressions, what's the area of the park? Well, we're going to learn how to find that. So to multiply monomials, such as 3 times x to the 4th power, 2 times x to the 5th power. And just recall that monomials have no addition or subtraction in them, only multiplication. So when we multiply monomials like this, we're going to multiply numbers by numbers, so the coefficient by the coefficient, 3 times 2. So you get 6 for the coefficient of the product. And then we'll multiply anything with a like base together. So x is a base, and x is a base. They match, so we can use the properties of exponents to combine those two. And we'll get x to the 9th power by adding the exponents. 6x to the 9th. Your turn, number 1. So in your turn number 1, we are multiplying 2x to the 3rd times 4x to the 7th. So multiply the coefficients together, 2 times 4. That gives us 8 for the coefficient of the product. And now we're multiplying x to the 3rd times x to the 7th. Add those exponents together to get 10. So that is 8x to the 10th power. In the next example, we're going to include a negative in there. And this is often confusing because students sometimes think that this is subtraction. But this is just a negative 1 times 7x, making it negative 7x. So now when we multiply those two numbers together, keep in mind that a negative times a positive is negative, so we're going to get a negative coefficient on the product. Negative 7 times 3 is negative 21, and there's our new coefficient. Then we'll multiply the exponentials together. We got x with a exponent of 1 there, we just don't write it, and then x squared, so add those two together, 1 plus 2 is 3, that gives us x to the 3rd power. Negative 21, x to the 3rd. Your turn, number 2. So we're going to multiply these coefficients together, 3 times negative 5. This looks even more like subtraction because it's in the second one. But since we have parentheses, that means it's automatically multiplication. So 3 times negative 5 is negative 15. So there's the coefficient of the product. Now we'll multiply x squared times x to the 6th. Add those two exponents together to get x to the 8th power. Negative 15, x to the 8th. Now in each of these, we've just had one variable. Now we're going to look at some expressions with more than one variable. Now we have to be careful about only combining things that have the same base. Well, let's start with the numbers. That hasn't changed. Coefficient times coefficient, that gives us 8 out front. Now we'll combine just the exponentials with an x base. Adding those exponents together, 2 plus 3 is 5, so that gives us x to the 5th power. Now we'll do the same thing with the other base, y. Add those together, 3 and 5 gives us 8, so we have y to the 8th power. 8, x to the 5th, y to the 8th. Your turn, number 3. Start again with the numbers. 4 times 5, that is 20. X to the 3rd times x to the 4th. Add those exponents together to get x to the 7th power. And now y to the 4th times y squared. And that is y to the 6th power. 20, x to the 7th, y to the 6th. Now we're going to look at an example where one of the variables doesn't have a match. So we'll still start with the numbers. Coefficient times coefficient, 3 times 6 is 18. And now we'd like to combine x to the 3rd with something, but there's nothing over here. So that just stays in our product unchanged, x to the 3rd. You can think of it as being like multiplying by 1 over here. We don't have any x's to multiply, so it's just 1. Now we'll do the y's. All right, got some matching bases here. Add those exponents. 4 plus 6 is 10, so we got y to the 10th. 18x to the 3rd, y to the 10th. Your turn, number 4. Now this one, keep in mind that if there's no coefficient out front, it's just a 1. So 1 times 5 gives us 5. Now we can combine the x's. We got matching bases here. 3 plus 4 is 7, so we get x to the 7th power. And then there's no match for a y squared, so that stays a y squared. 5x to the 7th, y squared. And we can have any number of terms or monomials multiplied, and each monomial can have any number of variables inside. So when you see a problem like this, just take it one piece at a time. So we'll start with the numbers. You got 2, and we're going to multiply them all. 2 times 4 times 3. So that's 2 times 4 is 8. 8 times 3 is 24. So the coefficient on the product is 24. All right, now we'll look at the x terms. You got x squared here, x to the 4th, and x. So we want to add together all those exponents. 2 plus 4 plus 1. So that is x to the 7th. All right, now we'll look at the y's. You got 1 y here, 2 of them here, 7 here, so that's 10 total. Y to the 10th. Now we'll do the z's. 5 plus 3 is 8, plus 4 is 11. Z to the 11th. 24, x to the 7th, y to the 10th, z to the 11th. And that brings us to your turn, number 6. Oh, I missed a z. That is z to the 12th. I knew there was something wrong there. So it should be z to the 12th on that one. All right, your turn, number 5. All right, so with your turn, number 5, multiply these numbers together. 5 times 4 is 20, times 3 is 60. Now look at the x's. We got 5 and 3 and 1, so that's 9 total. The y's, we got 2, 1, and 8, so that'll be 11 total. And 2, 3, and 4, that's 9 total. So 60, x to the 9th, y to the 11th, z to the 9th. Now this one, you got some negative coefficients. You've got to be careful when we multiply these. Got a negative times a negative, that'll be a positive. So positive 10 times 3 is 30. So we get 30 out front. All right, now we'll combine the x's. Got 3 here, and 2 here. Add them all up, and that's 8. So that's x to the 8th power. Here we want to add together 2, 4, and 7. So that's 13. Y to the 13th power. And I'll do the z's. So we got 2 z's here. So we don't have any z's here. So we'll skip over to this one. We got 2 plus 7 is 9. So z to the 9th power. 30, x to the 8th, y to the 13th, and z to the 9th. Your turn, number 6. Right now we need to start off by multiplying the numbers together. -7 times -4, negative times negative is a positive, so that's positive 28. Then we'll take positive 28, multiply it by -1, that represents -1 here, so it's negative 28 for the coefficient. All right, now we can combine the x's. We have 3 of them here, 4 of them here, that's 7 total, plus 1 is 8. So 8 x's, x to the 8th power. Now the y's, we just have one y here, no matches, so that will stay y to the 4th. And then the z's, 2 plus 5 is 7, plus 2 is 9. Negative 28, x to the 8th, y to the 4th, z to the 9th. Now we're going to look at some powers of monomials. All right, so as we saw in the warm-up, if we have just one thing inside some parentheses, this is just a straight up application of the power rule. Multiply the exponents together, and we get x to the 12th. So this will be one piece of what we're doing in larger problems. All right, your turn, number 7. Another power to a power, 5 times 2 is 10, so we get x to the 10th power. Next example, now we've got a coefficient on our exponential here. So when that happens, we're going to apply this exponent to everything that's multiplied inside the parentheses. So we've got two things here. We have 4 and we have x to the 3rd, two factors. We're going to apply it to the 4, so this becomes 4 squared times x to the 3rd power squared. Make sure you apply it to every single thing that is multiplied inside the parentheses. So 4 squared is 16. X to the 3rd to the 2nd power, multiply those exponents to get x to the 6th. So we get 16, x to the 6th power. Your turn, number 8. So we'll apply this exponent to the 3 first, to get 3 to the 3rd power, multiplied by x to the 4th to the 3rd. 3 to the 3rd is 27, so we get 27, x to the 12th power. Power to a power, multiplying those exponents, 4 times 3 gives us a 12. So we can have any combination of numbers and variables inside the parentheses. Next example, we got 5, x to the 4th power, y squared, all to the 3rd power. So now I've got 3 things multiplied. We've got 5, we have x to the 4th, and y squared. We're going to apply that exponent to all 3 of those things. So we got 5 to the 3rd times x to the 4th to the 3rd times y squared to the 3rd. Now I write out this step, and it's a good idea to do so when you're first encountering these types of problems. Make sure to keep things clear and organized. But once you get good, you can probably skip that middle step. 5 to the third, 125. X to the fourth to the third, multiply the exponents to get x to the 12th power. And then y squared to the third, multiply those to get y to the 6th. Your turn, number 9. So we're going to apply this outer power, 4, to each of these three things. So that gives us 2 to the 4th times x squared to the 4th times y to the 6th to the 4th. Right, 2 to the 4th is 16. Multiply these exponents. 2 times 4 is 8, so we get x to the 8th power. And then 6 times 4 is 24, y to the 24th power. All right, now let's do the one with coefficient and 3 variables. It's about as big as they get in this class. All right, now we got 4 things inside the parentheses. We have a coefficient. We got the x, exponential, the y, and the z. We're going to apply the outer exponent, the 3, to all 4 of these things. So that gives us 10 to the 3rd times x to the 5th to the 3rd times y to the 3rd to the 3rd times z to the 4th to the 3rd. All right, 10 to the 3rd. Anytime you have 10 to a power, the power tells us how many. 0, so that's 1,000. Multiply those exponents to get x to the 15th. Multiply those to get 9, y to the 9th. Multiply these exponents to get 12, z to the 12th. Your turn, number 10. Again, we got 4 things to apply the exponent to, 4 things being multiplied here. We got 7, we got x to the 6th, y to the 3rd, z to the 4th. So we'll start with 7. That is 7 squared times x to the 6th squared times y to the 3rd squared times z to the 4th squared. 7 squared is 49. So we got 49 out front. Now we'll do the x's. 6 times 2 is 12. So that gives us x to the 12th power. 3 times 2 is 6. So we get y to the 6th. And finally, z to the 4th squared. And that is z to the 8th power. Next up, now we've got a negative coefficient. Make sure when you square this, you square the negative along with the 6. Should look like this, negative 6 squared. That way we get negative 6 times negative 6. Negative times negative is a positive. We're going to get a positive 36 coefficient. All right, so I applied the exponent to all 3 things, the negative 6, x to the 5th, and y squared. So we get 36 5 times 2 is 10, so that is x to the 10th power. 2 times 2 is 4, so we get y to the 4th power. 36, x to the 10th, y to the 4th. Y to the, wait a sec. I wrote that one down wrong. This should be y to the 4th power here, not squared. So that's 4, and this would be 8. Your turn, number 11. So first thing we'll do is take negative 2 to the 3rd power. Negative 2 inside parentheses like that. X to the 4th to the 3rd. And y squared to the 3rd. Negative 2 to the 3rd power, that is negative 8. We get negative 8 coefficient. 4 times 3 is 12. We got x to the 12th. Y squared to the 3rd, that is y to the 6th. Negative 8, x to the 12th, y to the 6th. All right, now we're going to start combining multiplication with powers. In order to simplify these correctly, we have to remember order of operations. In order of operations, we start with parentheses. But since we're talking about monomials, we won't need to simplify inside parentheses. We'll go right on to the exponents. So the first thing that we're going to work on in all of these would be the exponent, the outer exponent. So let's say we were evaluating something like this. By the order of operations agreement, start with the exponent. What we do not want to do is multiply 2 times 4 to get 8, and then take 8 to the 3rd power. What we want to do is do 4 to the 3rd power first. 2 times 64, or 128. If we do 8 to the 3rd power, we're getting a much larger number than that. So, keep that in mind. Now we're going to look at an example. We've got x to the 5th power times x to the 4th squared. So we're going to do the exponent first. So power to a power. This is unaffected by the exponent, so just leave this as it is, x to the 5th. And when we simplify this, we're going to multiply the exponents. 4 times 2 is 8, so we get x to the 8th power. Now that we've simplified the exponent, now we can multiply. Now multiplying these, when we multiply, we add the exponents, so 5 plus 8 is 13, we get x to the 13th power. And that brings us to your turn, number 12. So we'll start with the exponent. X to the 4th to the 3rd, 4 times 3 is 12. So that gives us x to the 12th times x squared. Now, multiplying, so we add the exponents. 12 plus 2 is 14. Final answer is x to the 14th power. Now we're going to start with the exponent again, but this time we've got two things inside the parentheses, so we need to make sure to apply that exponent to both the 6th and the x to the 5th power. 6 squared is 36. X to the 5th squared is x to the 10th. Multiply the exponents, 5 times 2. All right, so there's a simplified version of this exponential. Bring down 2x to the 3rd. And now we can multiply these binomials just like we did at the beginning of the lesson. Coefficient by coefficient, 36 times 2 is 72. X to the 10th times x to the 3rd, add those exponents to get x to the 13th power. Your turn, number 13. We're going to start with the exponents, the outer exponent, and apply it to both things inside these parentheses, both the 4 and x squared. This thing is unaffected by the exponent, so we'll just bring it down, unchanged. 4 to the 3rd is 64. X squared to the 3rd power, multiply the exponents to get x to the 6th power. All right, now we can multiply the coefficients. 3 times 64, it's 192. Now x to the 7th times x to the 6th, add those exponents, 7 plus 6, that's 13, x to the 13th power. 192 x to the 13th. All right, now let's add in a few more variables. So let's take it one piece at a time. All right, I'm not going to affect this thing on the first step. Exponent doesn't apply to this, so we'll just bring it down. Now we'll apply this exponent to everything inside the parentheses, the 2, the x squared, and the y to the 3rd. All right, 2 to the 4th is 16. X squared to the 4th power, multiply the exponents to get 8, and that is x to the 8th power. Now we'll do the y's. 3 times 4 is 12. Y to the 12th. All right, now we can multiply these monomials together. 3 times 16 is 48. Then we get x to the 6th times x to the 8th. Add those exponents together to get x to the 14th. And then we'll do the y's. 5 plus 12 is 17. Y to the 17th power. Your turn, number 14. So we'll start with this one since it has the outer exponent. This one we're not going to change at all. 3 to the 3rd power is 27. X to the 4th power to the 3rd power. Multiply those exponents to get 12, so we get x to the 12th power. Y to the 5th to the 3rd, multiply those to get 15. So we get y to the 15th power times the second monomial. All right, now we can multiply straight across. We get 27 times 6. That's 162. Now we'll multiply x to the 12th power times x squared. Add those exponents to get x to the 14th power. Then we'll do y to the 15th times y to the 8th. Add those to get y to the 23rd power. 162, x to the 14th, y to the 23rd. A lot to keep track of in this one. First thing to be really careful of when we're applying the 2 power to everything inside here, we apply it to the coefficient, include the negative, so it's negative 3 squared. Negative 3 times negative 3 is positive 9. So we get a coefficient of positive 9 on this. X to the 5th to the 2nd power. Multiply those exponents to get x to the 10th. Y to the 1st power squared. Multiply those exponents to get 2, so we get y squared. Z squared squared, z to the 4th. Now we can multiply the coefficients. 9 times negative 5 will be negative 45. Combining the x's, x to the 10th, x to the 3rd. Add those exponents to get x to the 13th power. Now we got the y's, where the y doesn't have a match, so we'll leave it as y squared. Z to the 4th times z. The assumed exponent here is 1, so 1 plus 4 is 5. You get z to the 5th. Your turn, number 15. We're going to apply the exponent to everything inside here first. So we'll do the negative 2 first. Negative 2 to the 3rd power is negative 8. Then we got y squared to the 3rd. 2 times 3 is 6, so we get y to the 6th power. Z to the 4th to the 3rd, that is z to the 12th power. Now we'll multiply the coefficients. Negative 4 times negative 8. Negative times negative is a positive, so we get positive 32. There's nothing to combine the x's with, so we'll leave that as x to the 7th power. Nothing to combine the y's with, so that stays y to the 6th. And we'll combine the z's. 3 plus 12 is 15, so we get z to the 15th power. So up till now, only one expression has had an outer exponent. Now we're going to look at some where both monomials have an outer exponent. So make sure to simplify both of those first before we do any multiplying. So we'll start with this first exponent, outer exponent. Do 4 to the 3rd power. That's 64. Then we'll do x squared to the 3rd power. Multiply the exponents to get x to the 6th. And over here we'll do 2 to the 5th. It's 32. X to the 4th to the 5th. multiply the exponents to get x to the 20th power. All right, now multiply the coefficients, 64 and 32. It's 2048. Now x to the 6th times x to the 20th, add those exponents to get x to the 26th power. Your turn, number 16. All right, first exponent here, outer exponent, 2 to the 3rd is 8. X to the 3rd to the 3rd, multiply those exponents to get 9, x to the 9th power. And over here we've got 4 squared is 16. X to the 4th squared, 4 times 2 is 8, so that is x to the 8th power. Now multiply, 8 times 16, it's 128. X to the 9th times x to the 8th, add those exponents to get x to the 17th power. It's good to practice these more than once. So we're going to do one now with multiple variables. All right, applying the outer exponent first. So 4 squared, that's 16. X to the 3rd squared, 3 times 2 is 6, so that is x to the 6th power. Y to the 4th squared, 4 times 2 is 8, so that is y to the 8th power. And over here, 3 to the 3rd power is 27. X to the 4th to the 3rd, x to the 12th. Y to the 5th to the 3rd, multiply those to get y to the 15th power. All right, now we can multiply coefficients. 16 times 27. That is 432. Now we'll do x to the 6th times x to the 12th. Add those to get x to the 18th. And then the y's, 8 plus 15 is 23, so y to the 23rd power. Your turn, number 17. To the 4th is 16. X to the 1st power to the 4th power, that is x to the 4th. Multiply those exponents. 2 times 4 gives us 8, so that is y to the 8th. And over here we got 5 squared is 25. X to the 3rd squared, multiply those to get x to the 6th. Y to the 6th squared, 6 times 2 is 12, so that is y to the 12th power. All right, now we can multiply the coefficients. 16 times 25, that'll give us 400 for the coefficient. X to the 10th times x to the 6th. Add those exponents together and get x to the 10th power. Y to the 8th times y to the 12th. Add those to get y to the 20th. 400, x to the 10th, y to the 20th. All right, now we're going to look at the application. There was the introduction. You got the length and width of a city park represented by a couple of expressions. And this is often done if we don't quite know how big we want the park to be. It's based on some other factors. So we'll include some variables for flexibility. So if we want the area, we're going to take the length and multiply it by the width. So the area will be 12 x to the fourth, y to the third, y to the third. Right, and the area equals length times width. Shouldn't use x, length times width. And so we're multiplying those two monomials together. Through 12 times 5 is 60. X to the fourth times x to the third, x to the seventh, y to the third times y squared is y to the fifth. So the expression for the area would be 60, x to the seventh, y to the fifth power. Your turn, number 18. We're going to find the expression for the volume of the box. So what are you going to multiply to get that volume? We'll find the volume now. We need one more dimension. We need the height as well. So we're going to multiply length times width times height. And we have the expression for all three of those. We got 9xy to the third. Five x to the third times y, and for the height, 4x squared y to the fourth. Now it doesn't really say which one's length or width. Doesn't really matter. Multiplication's cumulative. We can stick those in anyway. Multiplying all this out, we got 9 times 5 is 45 times 4 is 180. And now we'll combine the x's. We have 1 here plus 3 here, that's 4, plus 2 more is 6. X to the sixth power. And the y is 3 plus 1 plus 4, that is 8. So that gives us 180 x to the sixth, y to the eighth power. So this is a foundational skill. We're going to be using it a bunch throughout the remainder of this course. And if you're going on in math, we'll be using this over and over again. So go practice.